Chapter 1st, Chemical Reactions and Equations. In this video, we will go through the study of Chapter 1st, Chemical Reactions and Equations. What are these? How are these formed? And what are the rules for making a chemical equation? Consider the following situations of daily life and think what happens when milk is left at room temperature during summers. It will get spoiled. An iron tawa, pan or nail is left exposed to humid atmosphere. Means in the moisture, what will happen? It will get corroded. Rusting will be there. Grapes get fermented. Food is cooked. Food gets digested in our body. We respire. These all are chemical reactions. In all the above situations, the nature and the identity of the initial substance have somewhat changed. Because milk when gets spoiled, somewhat changes will be there. When there will be rusting on iron nail, somewhat changes will be there in the color maybe in the color or taste. We have already learned about physical and chemical changes of matter in our previous class. Whenever a chemical change occurs, we can say that a chemical reaction has taken place, means there is some chemical reaction. Like the process of photosynthesis, chemical reaction is involved in it. Digestion of food in our stomach, that is also a chemical reaction. Chemical reaction is taking place. So how we will come to know that chemical reactions are taking place? So these are the following things you will notice in that. Change in state, means it can go from solid to liquid, liquid to gas or gas to solid. Change in color, evolution of a gas. Change in temperature, may the temperature increase or decrease. As we observe the changes around us, we can see that there is a large variety of chemical reactions taking place around us. We will study about the various types of chemical reactions and their symbolic representation in this chapter. For example, we take an activity. This is a conical flask and dilute sulfuric acid, that is H2SO4, is filled here. When you will put the zinc granules, means the pieces of zinc, in H2SO4, that is sulfuric acid, there will be release of a gas, that is evolution of a gas. And which gas is this? Hydrogen gas. When zinc pieces are dipped in dilute sulfuric acid, there is a evolution of gas, and it is a chemical change. Chemical equations. Activity 1.1 can be described as when a magnesium ribbon is burnt in oxygen, it gets converted to magnesium oxide. This description of a chemical reaction in a sentence form is quite long. It can be written in a shorter form. The simplest way to do this is to write in the form of a word equation. The word equation for the above reaction would be, means when magnesium ribbon is burnt in oxygen, that is magnesium plus oxygen, these are reactants which give the product magnesium oxide. So this is in the reaction when magnesium is burnt with oxygen, magnesium plus oxygen, these are reactants, and the product what we get, magnesium oxide, and this is a chemical equation. The substances that undergo chemical change in the reaction, magnesium and oxygen, are the reactants. As I told you, the new substance, magnesium oxide, formed during the reaction is the product. So when magnesium is burnt with oxygen, we get magnesium oxide. Magnesium plus oxygen, these are the reactants, and magnesium oxide, this is the product. So here is a rule written for writing a chemical equation. The substance that undergo chemical change in the reaction 1.1, that is magnesium and oxygen, are the reactants. The new substance, magnesium oxide, formed during the reaction is the product. So magnesium oxide is the product. A word equation shows change of reactants to products through an arrow placed between them. The reactants are written on the left hand side with a plus sign between them, that is magnesium plus oxygen. Similarly, products are written on the right hand side with a plus sign between them. If any other products are here, then we will use a plus sign for adding it. The arrowhead points towards the products and shows the direction of the reaction. Means when magnesium reacts with oxygen, we get the product magnesium oxide, and arrow represents the product. Writing a chemical equation. If you write it in words, it will be a very long equation, so we will use a symbolic form for that. Is there any other shorter way for representing chemical equations? Yes, obviously, we can use the symbolic representation. Chemical equations can be made more concise and useful if we use chemical formula instead of words. A chemical equation represents a chemical reaction. If you recall formula of magnesium, oxygen and magnesium oxide, the above word equation can be written as Mg plus O2 gives MgO. That is magnesium plus oxygen gives magnesium oxide. So this is the symbolic representation of the chemical equation. Now there is one more thing. Do you notice that the number of molecules of your oxygen are 2, whereas here it is 1. So it is not a balanced chemical equation. So the equations which are not balanced, they are called as skeletal chemical equation or unbalanced chemical equation. We will go through. So as I told, count and compare the number of atoms of each element on the LHS and RHS of the arrow. Is the number of atoms of each element the same on the both sides? No, because here oxygen are 2 and here only 1. But if we talk about magnesium, then here also it is 1 and here also it is 1. If not, then the equation is unbalanced, because the mass is not the same on the both sides of the equation, and you have read about the law of conservation of mass. Such a chemical equation is called skeletal chemical equation for a reaction. Equation 1.2 is a skeletal chemical equation for the burning of magnesium in air. So in this video we studied about chemical equations, and this is the example of chemical equation which is getting formed. When a sentence is written, it is quite long, so we write it in the form of words, and further we can write it in the symbolic representation. So that is a very short form for writing a chemical equation. Now in our next video we will talk over the balanced chemical equation, because here this is an unbalanced chemical equation and is known as skeletal chemical equation for the burning of magnesium in air, and make the number of atoms of each element equal on both LHS and RHS.